Have you ever wondered what it would actually look like to fall into a black hole? Not the theories, not the equations, the actual experience. What you would see as you cross the point of no return. Until recently, nobody could show you. Now, NASA can. I am your host. This is Cosmos Unknown, and what you are watching right now is the most accurate visualization of a black hole ever created by human beings. This simulation was built by Jeremy Schnittman, an astrophysicist at NASA's Goddard Space Flight Center. He ran it on a NASA supercomputer called Discover. The project generated 10 terabytes of data, roughly half the estimated text content of the entire Library of Congress. It took 5 days running on the supercomputer. On a regular laptop, and the same calculation would take more than a decade. The result is what you are watching right now. The black hole at the center of this simulation has 4.3 million times the mass of our Sun. That is not a random number. That is the exact size of the black hole at the center of our own Milky Way galaxy, called Sagittarius A star. This is what it would look like to fall toward the heart of our own galaxy. Now, here is the first thing you need to understand. If you are ever going to fall into a black hole, and obviously we recommend against this, you want it to be a supermassive one, not a small stellar black hole containing maybe 20 or 30 times the mass of our Sun. Here is why. Stellar black holes have extremely strong tidal forces right at the event horizon. The difference in gravitational pull between your head and your feet is so extreme that your body would be stretched out like a piece of spaghetti before you even cross the boundary. Astrophysicists actually call this process spaghettification. That is the official scientific term. But with a supermassive black hole, the event horizon is so enormous that the tidal forces at that boundary are actually gentle. You could cross the point of no return without feeling anything unusual at all. You would not know you had crossed it until you tried to turn back, and realized you could not. The event horizon of this simulated black hole spans about 16 million miles. For reference, the distance from Earth to the Sun is about 93 million miles. So the event horizon alone is about 17% of the distance from where you are sitting right now to the Sun. As the simulation begins, the camera starts about 400 million miles away, and what follows happens in real time, about 3 hours, as the camera accelerates toward the event horizon, executing nearly 2 complete orbits along the way. Notice what is happening to the light around you. The glowing ring surrounding the black hole is called the accretion disk, a flat swirling cloud of superheated gas spiraling inward at enormous speed. As the camera accelerates, reaching speeds approaching the speed of light, the light from the accretion disk becomes amplified and shifted. Looking forward into the direction of travel, everything appears brighter and whiter. The stars ahead compress into a bright ring. The stars behind fade. This is the same effect as a race car approaching you. The sound rises in pitch as it comes toward you and drops as it passes. Except here, it is happening with light itself. Now look at the photon rings. Those glowing structures orbiting even closer to the black hole are rings of light that have actually orbited the black hole 1 or more complete times before reaching your eye. You are seeing light that has traveled around the black hole and is arriving at you from behind, from a direction it was never originally traveling in. Space-time itself is being bent. At the event horizon, something fundamental changes. Space-time itself, the fabric of the universe, begins flowing inward at the speed of light. The speed of light is the absolute cosmic speed limit. Nothing can travel faster, and space-time is flowing inward at exactly that speed, which means that anything inside the event horizon, no matter how fast it moves, no matter what direction it travels, is being carried toward the center. There is no escape. Not because the gravity is too strong to fight, but because the space you are moving through is itself moving inward faster than anything can move outward. Once inside the event horizon, the camera has exactly 12.8 seconds before it reaches the singularity. From the event horizon to the singularity, only 79,000 miles. In those 12.8 seconds, everything the camera is made of will be compressed into a mathematical point where the laws of physics as we understand them completely break down, not slow down, not become difficult to calculate, break down entirely. Our equations produce infinities, infinities that have no physical meaning. which tells us that our understanding of physics, as complete as it is not complete enough to describe what happens at the singularity. But Schnittman also modeled a second scenario. What if the camera approached the event horizon, got very close, but never crossed it? In this version, the camera orbits close to the boundary and then escapes, flying back out to safety. The round trip takes 6 hours. But here is the extraordinary part. When the camera returns to its starting point, if there had been an astronaut on board, she would be 36 minutes younger than the colleagues she left behind on a distant spacecraft. 36 minutes. Not because of any biological process, but because time itself passed more slowly for her, near the enormous gravity of the black hole and moving at speeds approaching the speed of light. This is not science fiction. This is a direct, measurable consequence of Einstein's general theory of relativity, confirmed by experiments here on Earth. And Schnittman made one more observation. If the black hole were spinning rapidly, like the one depicted in the movie Interstellar, the time dilation would be even more extreme. The astronaut might return not 36 minutes younger, but years, or even decades younger than the people she left behind. The universe has no obligation to make sense to us. It simply follows its own rules, and those rules are stranger than anything we could have invented. What you have been watching is not special effects. It is a mathematical model, built from Einstein's equations, run on one of the most powerful computers NASA operates, producing the most accurate picture we have ever created of one of the most extreme environments in the universe. This is what science looks like, not guessing, not imagining, calculating, and then showing you. This is Cosmos Unknown. If this video changed how you think about black holes, subscribe, hit the bell. Next video, we go somewhere even stranger. I will see you out there.